I'm going to show you how to make a spreadsheet of chemical reactions. So this is a synthesis of hydrobromic acid with ethylene glycol to create the intermediate 1,3-dioxylane. So here is how you would make that into a Excel chart. And I know there's a lot of steps missing here, but I just got a little bit too tired to go through with all of this. So here is actually our graph, and what I want to do here is change the total amounts. So I look back to the limiting reagent. Let's go back to see, I didn't realize I could only redo a certain amount into the future of this. So you wouldn't have theoretical and actual, like I didn't do this experiment. So they're both theoretical. The idea is you'd want to do this before you get into lab so you can adjust easily on a Excel chart and then get to visualize it before your lab starts. So here my total is like pushing the limit because the total a test tube can fit is 10 milliliters in a standard chemistry lab, and this should definitely always be supervised. So here let's go ahead and look at what the limiting reagent was. It should be LR. Yeah, so you're gonna, I mean, this is like tiny titrations. 5 grams of this is a lot. So let's save everyone some money and let's lower it from 5 grams. So the green is when I highlighted because the procedure lab is going to tell you, let's say for example, add 6 milliliters of ethylene glycol and 3 milliliters of hydrobromic acid, but this would be in a fume hood and you wouldn't use that much hydrobromic acid. So let's change those milliliters to like 0.5. Oops. Wrong area highlighted, so 0.5 milliliters. And now with the conversion of density, density is 1.49. You're going to end up with 0.745 grams used. In all actuality, you probably would even use less than that. So I highly doubt you would be pouring this in the synthesis. Who knows, but I would say let's actually say you wanted 0.05. You're not going to pipette this amount. So, oh, and look, it was so insignificant, the amount, that it's not showing for some reason. So now I've got to ask myself, oh, okay, so that's because limiting reagent amount is so small. So let's make it all apples to apples here. Equals 10 minus, oops, this number, and then equals 10 minus moles. Okay, and this was 7.4, 7.5, 7. So why is this not equal? Because technically you're not going to do that. Okay. Anyhow, this will give you an idea ratio-wise of just how tiny these molecules are. And I think that's the entire basis of why it's done this way. So let's go ahead and change our final product. And I should probably make a column of just that. So really it's going to be And then this will be, oops, well, Excel doesn't work that way, so here's, we care about milliliters, and we care about this. So let's go ahead and, milliliters product, milliliters acid, oops, and then milliliters of other, reagent. So here, let's go ahead and enter equals, and milliliters has already been normalized. It's the word I'll use because it's been converted based upon density at room temperature. Okay, and here's our smallest one. So let's take a look at these ratios. And our total is going to be equals 10, total size of the test tube minus whatever that amount was. Okay, equals 10 minus this amount. Because what I'm trying to do here is give an idea of what air would look like. So let's go ahead and go back to our graph. Okay, so, control, select data, and here are my horizontal categories. I have expanded it, so now it's going to include these. And now my different categories. I'm going to have, let's see, what was this one? Okay, well, let's just start with that. Right, so here's product, here's milliliters of acid. All right, well, we have now made this into a cooking class. So synthesis of, like, wait a second, why is product showing up first? I really don't like that. So anyways, let's just forget that happened. Okay, well, so milliliters product, there we go. Whatever, select data, total, I have another one. Let's make this one product, and then products Y values are going to be these two. Okay, and now I'm adding another one. That will be acid, and then acid is going to just equal these two. And lastly, I'm adding reagent. Oops, reagent, the name, yep. Reagent name is that, and it is simply these two. All right, I want it to go in the same order it did here, so reagent will go first. Let's just drag it up. Oops. I thought that's how that worked. Oh, it's up here. Okay, reagent plus acid yields product. Let's see. Oh, that's cool looking, but not quite what I was looking for. So Looks awesome. Okay, so let's do select data. Let's delete these 3. Okay, horizontal axis here. Let's check it out. We need just to insert one more. So I wonder, oh, I see what happened. Okay. Okay, select data. Entire chart range is going to be oops, I don't need that much. This. Okay. Perfect. So let's change this color to now make life a little bit easier. And let me make this color a little bit darker so it's easier to see, and up the transparency. Same with our acid. Cool. And I want to now go in here, and I really don't want all these lines. Let's just go into style. Nope. I like the colors I chose, even though it's like a giant Easter egg. Okay, I just want outlines, and I think I am good. So here's our cylinder. You can change gap width. I think that looks the most realistic. Depth. I mean, that works. So do I want a fill? That takes up a lot of space. Oh, that's pretty cool. I like how it's orange, but makes it a little bit hard to see. So let's go through and just add that to all of them. Solid fill color. I needed a border, I wanted a border. Cool. And then lastly, going back and adding a border. Preference. Right. So now back here, kind of notice that my font changed too much. So, ooh, I really like how this looks. Okay, well, this is just my preference. Yours can be different. And these are total amounts. So this is when you're looking at what percentage is our limiting reagent. It gives a really cool kind of visual. And I mean, you can always change these solid line colors if you like. So like here, instead of doing that, I can just give it a little bit of a pop, not crazy anything, you know. And here can do that. And I mean, I think most realistically you would have kind of like a blurry color between. Again, leave that all up to you. I wish there was a way to make them rounder on the ends, but the best part, in my opinion, of these is seeing our reactions. So let's go through now and look at how we can kind of synchronize these. Okay, make this a little bit smaller, and I hope that is large enough. All right, so these are theoretical versus, like, of course, real life, but it's nice when you have this, and then you can come in, and while you're doing this in lab, you've taken notes in your lab notebook, and you can do like actual milliliters of what you end up with. Now, you're not always going to, let's say that you're titrating this amount, and okay, we see our limiting reagent here. So let's say 5 drops equals 1 milliliter. And let's say I achieved this with 2 drops. So for example, I can come in and just, like, after lab, I'll say like, okay, I used 2 drops. I used 2 drops, and I'll show you some shortcut. It's not really a shortcut. So here you're going to say equals this amount of drops, and drops of what? HBr. Okay, so now we know if 2 drops equals 5 milliliters, then we can say like, okay, so that was equals 10 divided by 5, and pardon me, I'm not super math savvy. I know that there's a shortcut mathematically to do this. Okay, does that look right? No. So, I know here if I have 5 milliliters of something, then that's like saying if I use 2 drops, and that's 5 milliliters, I can always multiply it. So 4 equals 10 milliliters, and then that's a little bit easier to work with, less steps. So equals 4 divided by 10 is 0.4. So here I would have actual milliliters used equals this number. So now let's say that I'm in a fume hood, I'm using all glassware, and my pipette is plastic, and let's just plug this in to what was used. So 0.4 is used, and you're like, okay, this is still, I gotta reduce something here. So let's try reducing the amount of ethylene glycol, because what's your total product at the end? You want to know like the mass of your total product. So here it is. So let's just use 5. Okay, 5's nice, 5's decent, right? But let's say that in my titration that it reaches full saturation. So this is why we go through and do this, right? So because how these acids keep working is like you add HBr, and then it just keeps adding in on itself until full saturation, and then before you know it, all of your oxygens are out of space. They're all out of space, and then you just have like HB floating in the rest of your mixture. So like your aqueous mixture, you have all these extra ions and things floating around. Okay, well, my spreadsheet ions are not working very well. You just have all these little extra molecules and then H2O, all of them, and it's like, let's balance them. But no, it's like, let's get this right. Let's not use too many. So this is why you would use an experimental design, and you would say, like, at what amount of milliliters am I going to fully saturate this amount and have 1,3-dioxylin? So you would add maybe like a phenol to it, one that changes colors, like a, can't remember the name right now. Anyhow, that's not the point. The point was to show something pretty. Let's say that my actual amount used was 4 drops. And let's say that I theorized that, 0.5 was going to do it. And instead I used 6 drops. Well, here I can see that my actual amount used varied from the, like what was actually used. So let's just do equals, was this acid, and that's milliliters, yep. Okay, so then we can take the difference, so equals this minus that over total, blah, 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 and you can get your percent yield, which I don't feel like, I'm not a chemist, I studied biology, I just enjoy this, and I probably will never use it in real life, but I wish I had done this prior to my labs because it would have given me a better understanding. And back to how this could work as well. So let's just say that instead of hydrobromic acid, I used HCl, because it's like, hold on a second, this is an intermediate state. What do I actually end up with? So let's just change our molar masses. Let's say I used an acid that was attached to, so bromine's heavier than chlorine. I don't know, let's just say it was 30 less. So here is how it changes. Let's say that you just used, so hydrochloric acid, less density, your intermediate, would you end up with 1,3? 1,3 is meta, or would you end up with something else like a chlorine, bromine? So I think chlorine is a stronger meta director, yeah? Anyhow, someone who's more experienced with this can reach out to me, and I will gladly work to change mine all around because I enjoy doing this stuff. You know, the same way that like a magnesium is going to be still an anhydride, but weighs less than sodium and smaller molecule. So you have to just kind of figure it out here. And these were just ratios, molar ratios. I didn't even take into consideration the weights. And this is a scale. So here is scale 1 and here is scale 2. So scale 2 was basically normalized. So taking your big number, dividing it by what was found or something. I'm tired. I did this during lecture. So I don't necessarily remember. And here's my scratch work, right? So again, when you just pull this up, you start from changing the fill color. I'll do a solid one and lots of transparency. This one we won't do border, and I will, it's kind of cool. Okay, again, solid. Oh, you know, it's fun are the gradient fills. because that's like your in real life type deal, what it would look like in lab. Transparency, radial, let's do linear, and then gradient fill. It's like, why isn't it going like, oh, nice. Okay. Oh, well, that's cool. So you also have angle. I don't know. Well, anyhow. Time for me to get some sleep. Chemistry always makes me tired. Thanks, y'all.